LISA is part of the search for our roots, the desire to look at the beginning of our universe.
LISA will be the largest structure ever created by man, a triangle with laser arms that are 5 million kilometers long.
LISA is poised to uncover one of the deepest secrets of the universe. It will measure extremely weak gravitational waves which carry hidden information about the Big Bang. Glitches must not be allowed to occur.
That's why critical components are tested in an advanced mission. In our case, this is LISA Pathfinder, beating the trail for LISA.
LISA Pathfinder is a space mission too, but where LISA has 3 satellites, LISA Pathfinder flies only 1.
Basically, LISA Pathfinder is one arm taken from LISA and shrunken down to a length of 30 centimeters from 5 million kilometers. We have 2 free-falling test masses, 2 gold cubes, but they're in one satellite and fly along next to each other. We have a small laser interferometer between them to find out if the disturbances acting on these free-falling test masses are really as tiny as they're designed to be.
Development of the satellite is completed. The laser is the heart of the scientific mission. It was developed and constructed by TESAT Spacecom. The first and most critical German component in this international collaboration to undergo a simulated rocket launch before delivery is the extremely delicate light source.
During launch, the rocket is vibrating wildly in all parts. When a strong rocket engine really blasts off, the rocket will shake in a lot of frequencies and very powerfully indeed. If you work with optics in lab conditions, you're likely to panic once you see what that is going to do to your beautiful, fragile laser. A space-worthy laser must be designed quite differently to survive the brute forces of a rocket launch.
There are no rockets or engines here. In this place, there is only a small lab, a shaker, 8 sensors and a computer. And the laser, which will be rigorously put through its paces, is already snugly fitted in the shining golden shell that will protect it during its time in space.
The shaker works like a loudspeaker and can exert stress only in one direction, along one axis. So you can't test all 3 axes, and therefore real-time stress at once. You have to test axis after axis.
In a real rocket launch, the laser will shake in all directions at once. During testing, this motion is separated into 3 individual axes. For 2 days running, the engineers at TESAT conduct innumerable individual test series. The trick lies in the variation of measurements. A stress test is always followed by a measurement to check the resonance frequencies, which should not have changed at all.
The worst case you could imagine would be that something actually shakes loose and starts rattling around in the housing like a coin in an old-fashioned collection tin. In principle, that's what we're doing here. Our measurements are much more sensitive, obviously, but we're looking at the resonances. If they change even a bit after shaking, you know that something has moved that shouldn't, and you have to analyze exactly what the source of that error is.
The shaking along the vertical axis is especially critical for the laser optics, because forces during launch will be greatest in this direction. So the final test runs will see the laser going up and down faster and faster. The strain is enormous. The laser is accelerated to about 17 G. A jet fighter must only endure 10 G forces in a tight turn. If this test goes well, the laser will be approved for flight on the LISA Pathfinder mission.
We can see the results of our test series on this monitor. The curves show the mechanical integrity of the laser unit, which is to say that the equipment didn't suffer during rigorous stress testing. There were no signs of mechanical degradation. That's why these 6 overlapping curves here fit on top of each other so beautifully.
The laser is now cleared to fly. After 5 years of development, this first and most important German contribution to the international collaboration working towards LISA will be installed in the LISA Pathfinder satellite.